Welcome back. In the previous video, we learned about arithmetic operator and relation operator. Now here we are going to discuss one more interesting operator, that is logical operator. Now what is a logical operator? Logical operator is basically based on the concept of logic gates that we used to learn in physics. Logic gates. If you remember, we had many logic gates, out of which AND, OR, NOT are the three logic gates on which logical operator is based. So basically, logical operator works on the principle of AND, OR and NOT logic gates, and here in Python we denote logical operator as NOT, AND, OR in lowercase letters, right? So basically, logical operators takes logical value as an input and returns a logical result. That is, whatever the values are given as an operand to the logical operators, those values are in the form of true or false. That is, it takes Boolean value as an input and returns Boolean values as a result. So basically, we are having, as I said, three logical operators, NOT, AND and OR, where NOT is an unary operator that takes only one operand and works on that operand, and simply it gives a negation of the operands as a result. That is, if the value supplied to the NOT operator is false, the output we get is true. If the value supplied to the NOT operator is true, the output we get is false. This is how NOT operator works. The second one is AND operator. The Boolean expression of AND operator is f equals to x dot y, means a dot operation is applied between the operands. So if both the inputs are false or any of the input is false, then the final result that we get in AND operator is false. You can simply check here applying the values in Boolean expression. If any of the value of x and y will be 0 or both will be 0, the value of f will be 0. And if both the values will be true, then only the final result will be true. That is the working of AND operator, right? Now the next comes is your OR operator. The Boolean expression of OR operator is f equals to x plus y. So here, whatever the values we give as an input, whatever the values we give for an operator, if those values are, if both the values are false, then only the final result will be false. In all other cases, if both the values are true or either of the one value is true, then the final result will be true. So this is the working of OR operator, right? So basically these are the three operators, AND, OR and NOT. Now the question is, what is the role of the logical operator, where we basically use it? Okay, so let us understand this with an example. Suppose that we are having three values, v1, v2 and v3. Now I simply ask you a question. Just tell me that whether the value v2 is the greatest among these three. So what you will do? You will simply compare the value of v2 with v1 and you will compare the value of v2 with v3. And in both the comparison, if you get that if you get that v2 is greater than v1 and v2 is greater than v3, it means the v2 is greatest. So what we will do here is, we will simply compare v2 by v1 if v2 is greater than v1, and in the second case we will again compare v2 by v3 if v2 is greater than v3. Now in these two comparisons, if both the results we get is true, right, then the final result is true, that is V2 is greatest. So what we have to do is, to conclude this final result, we need to concatenate these two comparative results, right? We need to concatenate these two comparative results. Now to concatenate these two comparative results, which operator we will apply here? As in the normal sentence what I was speaking, I was saying that if V2 is greater than V1 and V2 is greater than V3, then V2 is greatest. So what I use in between? And. So here this and operator will be applied, because this is the operator which has a condition that if both the values will be true, then only the final result will be true. So to conclude the final result, in this case we have make use of AND operator. Okay, so basically logical operators are used to conclude the final result if the final result is dependent on more than one comparison. Okay, so this is the role of logical operator, right? Now there is a special case with logical operator. Suppose instead of using the logical operator with logical values, if you are making use of it with some other objects, such as suppose if you are making use of it with an integer value. Suppose if I say 5 and 6. Okay. Now if you are applying AND operator between this 5 and 6, then what the result will be? If you are applying OR operator between 5 and 6, then what the result will be? See, in this case you need to understand that what is the truth value of these objects, means of these integers. So in the case of 0, the truth value is false, right? And your result depends on the truth value of the first operand in both the cases. Okay, in the case of AND, if the truth value of the first operand is false, then it will give you the result as the first operand. And if the truth value of the first operand is not false, then it will give you the result as the second operand. Okay, means 5 and 6 will give you the result 6, and if it will be 0 and 6, then it will give you the result as 0. Okay, so this is with AND. Now if we talk about OR, 5 or 6, what result it will give? Here the first operand value is not false. Okay, here the first operand value is not false. In this case it will give 5 as a result. If it would have been something like this, 0 or 6, means the value of the first operand is false, then it will give 0 as a result. Okay, to but better understand, see here the example. Suppose the value of the first operand is 5 and I have applied and the value of the second operand is 6. Now the first operand's value is not false. In this case, what we will get the result? The second operand's value, that is 6. And if the first operand's value will be false, suppose I have written 0 and 6, in this case what it will give the result? It will give 0 as the result. See here. Now applying OR operator, if it is 5 or 6, now the first value of this is here, it is not false, so it will give 5 as a result. And in case the value is false of the first operand, then it will give 6 as a result, right? In case of NOT operator, it simply gives false or true. Okay, it simply gives false or true. Suppose if I write not 5, it is giving false because it is treating 5 as a true. So simply it is negating the value of 5, it is just reversing the value of false from true from false, right? So this is how the logical operator works. Now the next comes is your bitwise operator. Now what is a bitwise operator? Bitwise operator working is similar to that of logical operator, with a difference that bitwise operator works on individual bits of the values, right? It works on the individual bits of the values. Just what I mean to say is, suppose if you are applying an operator on 5, okay, if you are applying an operator on 5, so first what it will do, it will convert the value 5 in binary form, and then it will work on the individual bits of the values. This is how bitwise operator works. Okay, so we have not bitwise operator, and bitwise operator, or bitwise operator, and XOR bitwise operator. The working of and OR is actually same as we have learned in logical operator. Okay, so just first a recap of and bitwise OR. It is denoted by ampersand sign, and OR is denoted by a pi sign. Okay, so see here, if both the values are false, so the final result will be false. If one of the value is also false, then the final result is false. If both the results are true, then only the final result is true. This is the working of bitwise AND, similar to that of logical AND. Here again, if both the values are false, then only the final result is false. In all other cases, the final result is true. This is the working of bitwise OR. The difference exists in the case of bitwise NOT operator, and XOR operator is of course a new one. Okay, so let us understand bitwise NOT operator. Unlike the logical NOT operator, which was simply used to convert the value from false to true and true to false, bitwise NOT operator works somewhat different. Okay, so what it does, it simply gives the ones complement of a value. Okay, it simply gives the one complements of a value. Okay, so I will simply give you an example. Suppose that I am applying a bitwise NOT operator on the value 5. Okay, I am applying a bitwise NOT operator on the value 5, which is denoted by this sign. Okay, tilde sign. Okay, so what it will give you the result. So first of all, the value of 5 will be converted in binary form, and then this bitwise operator will be applied. So here what it will happen, it will simply convert the 101, that is binary form of 5, in ones complement. So the moment it will convert it into ones complement, what we will get is all the values will be reciprocated. The 1 will be converted to 0 and 0 will be converted to 1. So here we get is 0, 1 and 0. Now because this was 5, means it is a positive 5. So the sign bit will be of positive. Okay, now what will happen, once the ones complement is calculated, the sign bit will also be changed, and the sign bit will go to negative, from positive to negative. Now once the sign bit is changed, because the negative numbers are represented in 2's complement, so again after 1's complement the number will be reconverted to 2's complement, because it is a negative number. So here the 2's complement will be taken out. Same numbers will be, I'm just telling you how to calculate the 2's complement. From the right, you start writing the same numbers till the first one is encountered, and the moment the first one is encountered, after that whatever the values are, it will be changed. It will be changed from 0 to 1 or from 1 to 0. So here we will get 1. Now it was positive 5. Here it will give you negative of this number. Okay. So 110. What is this 110? It is 6, and this sign will be added because here it was positive. So here it is negative. So here we get minus 6 as a result. Okay. So this is how bitwise NOT operator works. It simply takes the ones complement of a number, right? Now comes the XOR operator. Okay. Now comes the XOR operator. Now see, XOR operators, if we talk about the Boolean expression, it is something like X operated Y. Now the expansion of X operated Y is X dot Y bar plus X bar dot Y. Means this is the final result how we calculate of XOR operator, right? So when the values are given supplied to the XOR operator, if both the values are of the same kind, that is both the values are 0 or both the values are 1, means both the values are true or both the values are false. In this case, the final result will be false. And if both the values are unlike, that is 0 and 1 or 1 and 0, then only the final result will be true. So this is how XOR operator works. Now let us understand the working of AND OR bitwise operator. Let's suppose we are working on the values of X as 5 and Y as 3. Okay. So what is the binary equivalent of 5? We know that binary equivalent of 5 is 101. And what is the binary equivalent of 3? It is 011. Right? Suppose these are the values and we are applying bitwise AND operator. See here, bitwise AND operator is applied on binary equivalent of 5, that is 101, and binary equivalent of 3, that is 011. Now how this operator will work? As I said, it works on the individual bits of a number. So it will start working from right hand side. It will take the first value of its first operand and the first value of its second operand, and it will apply AND on both these values. So 1 and 1, what we get is 1. See here, 1 and 1, what we get? 1. So this is the first result we get. Now shifting on to the next value, that is 1 from right hand side, and here we get 0. So 0 and 1, we get 0 as a result. And the third value is 0 and here it is 1. So 1 and 0, we get again 0 as a result. So finally we get is 0, 1, 1, which is equivalent to 1 in decimal number. So this is the result of AND, right? Now coming on to the next, that is bitwise OR. What is the working of OR? Again the same example, value of X is 5 and Y is 3, and we have applied OR operator, right? So again individual bits of the numbers will be taken from right hand side. So here 1, from here 1, what we get is 1 or 1, the answer is 1. Then the second values will be taken 0 and 1. So 0 or 1, 0 or 1 gives you again 1. The third value from the right hand side, here 1, here it is 0, 1 or 0, again here gives it as 1. So we get 3 ones, and the binary equivalent of decimal equivalent of these 3 ones will be 7, right? So here we get the result 7. So this is how bitwise AND OR operator works. Now here is one rectification on the timestamp of 8th minute and 52nd second. In the flow, I just simply wrote 0 here as a result, but here the result will be 6. It was a mistake in the flow of lecture, so I'm extremely sorry for it. It is not possible to record the video again, so I have just simply put here the rectification remark. In the next video, we will be talking about operators, precedence and associativity. Till then, take care. Goodbye.